All right, so cyanohydrins are another thing that can form from aldehydes and ketones. So essentially, if we have aldehyde or a ketone and we have Cn minus mixed with some weak acid, we're going to get an equilibrium where essentially the Cn minus would deprotonate the acid, and that would generate HCN plus water. And essentially here, we're always going to have enough Cn minus to fully protonate our Cn. So, and just to kind of see where this is a downhill reaction, the H3O plus we know is a pK of negative 1.7. We don't know HCNs, but I do. It's 10. So essentially, we're going to have a lot of this around and also some additional Cn minus as well. So we have more Cn minus around. That Cn minus is going to be, it's negatively charged, it's going to be attracted to partially positive things. That's why it picked off that hydrogen. The hydrogen's partially positive, but that's also why it would add to the carbonyl carbon. At that point, we would have our O minus, our Cn, and our H, and we also have the HCN that we just mentioned is around in solution. So at this point, a proton can transfer, so essentially at this point we're wondering, well, what's the more stable acid? So what's more acidic? We know HCN, I just said, is a pK of 10, and this O minus is also going to be really basic. So that can pull off that proton, and that would lead to the cyanohydrin plus Cn minus. So essentially, which side of this equilibrium is going to be favored? Well, the pK, like I said, of HCN is 10. What's the pK of this alcohol going to be? Well, it's going to be similar to other alcohols that we've heard of before, so it should be around 16. So under mildly acidic conditions, so with an equivalent or more of this hydronium ion around, the cyanohydrin is going to form because essentially we're going to form the alkoxide, which will then be basic enough to protonate from the HCN, pushing the equilibrium that direction because this is the strongest acid in solution. And under acidic conditions, it is favorable to form that cyanohydrin. But what we're going to see in a moment is things change a little bit when we add base to the reaction. So that's right now. All right, so we just saw that mild acid will help us make the cyanohydrin. Well, how do we remove the cyanohydrin? And it turns out that we add base to the reaction. So H3O plus allowed us to put it on. What happens when we add OH minus? Well, that OH minus is going to act as a base, pulling off the proton that is most acidic. That's going to be the OH proton. And at this point, we will generate the oxonium, or the alkoxide ion. And essentially we have to ask ourselves, well, what's more stable, O minus or Cn minus? Because the relationship between this and the products is essentially us kicking out the Cn minus. So what's more stable, O minus or Cn minus? And thinking back to our acid-base chemistry, the stronger the acid, the more stable the conjugate base. So yeah, let's even write that here. Stronger acid, more stable conjugate base. So take a minute, write yourself an explanation. Is this side favored or is that side favored? Which side of this reaction of this last part is favored and why? And then come back. So you've done that, great. So essentially we have to ask ourselves, is this O minus more stable or is the Cn minus more stable? So we can look at the conjugate acids of those. So HCN has the pKa of 10. The and that's the conjugate acid of that. The conjugate acid of that would be essentially an alcohol. And an alcohol has a pKa around 16. So which one is the stronger acid? HCN is the stronger acid. So that tells us that CN minus is a more stable conjugate base than O minus. So that being said, that explains why under basic conditions we would favor the forward direction of removing that cyanohydrin, the forward direction as it's written here, because we're forming the most stable anion. And we could say the same thing about this one. This anion has the conjugate acid of water. That pKa is 15.7. So we're moving away from the less stable anions and forming the more stable anion. So we put on cyanohydrins with acid, we pull them off with base. So that's about that.